But let's go back. Let's do this. Let's try to reframe things a little bit. Area is, as a definition, what is area? Length times width is a formula for one. It's a what, Carter? It's the amount of space inside a two-dimensional shape. Okay, so let's take a look at, this is just going to be copied from the book. Okay, so if I had 4 times 4 like that, let's put a center point here. The area of the square would be, what would it be? Huh? Wait, what?
44. Oh, 16.
Okay. 4 times 4, or 16, right? Side squared. Length times width, if you will, but they're both the same. So suppose, then, let me get my little thing out here, and let's try to show those just really quickly, okay? And you don't have to use perfectly straight lines for yours. That suffices. That's great. Okay, so the area is 16. And you can see, you can count 16 blue, like little blue squares inside, right? And that would represent the area. So let's change it up a little bit. Let me see if I can find something just the right shape here. I don't know if I have the right size or not, so I might have to just use freehand it. All right, that one's certainly not perfect. So, what if I now ask you, find the area of the circle? So, first off, would you say that it's more or less than 16? What are you doing? What did you say, Sophia? Less. Why?
Because it doesn't fall in the circle because it doesn't have edges.
Some of these are outside the circle, so they would not be included in the area of the circle. What are some of the dimensions or values we use to describe the size of a circle? The diameter of the circle equals 4. Everybody see that? It's 4 across. So the radius, what is the radius?
2.
Okay, it's 2. But the area of the circle has something to do with either the diameter or the radius or both. But it's not as simple as just looking at it and think, well, that's about half, right? Or that's about a quarter. It's not that simple. But since it's a circle, do you remember a particular letter or value that's associated with circles? Allie? Pi. Yeah, you won't forget that cookie. So, guess what? It's as simple as a formula. The area of a circle is pi times r squared. Okay? Now, I wanted to remind you of something. What is pi close to? What do we use to estimate pi as? 3.14. Okay, good. 3.14. Now, I want you to think about something. If I took my radius, which is 2, and I squared it, I get 2 times 2, that's 4. Which is a little bit too much for that corner if I'm talking about the circle, right? So if I start coloring in my circle here, you guys can tell that there's going to be some whole squares and there's going to be some that are left out. So pi represents that portion of those that are included. And we take that relative to the radius. So the area of this particular circle, that would be pi times 2 to the second power, which is 4 pi, or 12.56. Roughly. Now I estimated. I estimated because pi is irrational. Pi is a number not related, like we can't say pi is exactly 3.14 because it's not. Pi is actually not a number but a ratio. But that's a whole nother class. So, that's it. Now, At the beginning, did you guys tell me that the area would be less than 16? You can see that it will be less than 16. There's the proof that it is less than 16. So the area of a circle, again, is just pi r squared. It's a formula. It's one you need to memorize. Okay? And you just use the size of the circle in pi. That's pretty much it. So if we do just one more example of this, because there's not a lot more to it today. Find the area of a circle, circle whose diameter, let's see, what do we want the diameter to be? How about 14 centimeters? You can draw it. You don't have to. Man, that circle looks rough. But if that's all you're given, find the area of the circle whose diameter is 14 centimeters. Oh, I had it all along. You don't have to draw it. But for the sake of this problem, since it's an example, I am going to. While you're working on it, I'll just draw it. 14 centimeters. Oh, it might not fit. Let's see how well this works here. Drawing a bird circle. We're trying to. No.
That is a perfect circle.
Oh, whoops.
Oh, never mind.
All right. So it didn't hold its can't give that word away yet. It didn't hold its radius. So it's supposed to end here. It was supposed to end here. All right. So I told you that this distance in the problem is 14. Can we use the 14, or do we have to find something else to be able to find the area of this circle? Well, we got to use that, but that's not all. You see, the area formula for a circle is pi times radius squared, not the diameter. So how do we find the radius given the diameter? It's 7. It's half. So r equals 7. So it's going to be pi times 7 squared, which is 49 pi. I am satisfied to leave it that way. Bless you. But sometimes your book may ask you, hey, why don't you go and estimate by using what for pi, Sophia? 3.14. So all we do from there to find the estimate, because that's what it is to round it. 49 times 3.14 equals 153.86. I'm going to put a little squiggly line there. Centimeters squared. If you don't put the squared, it's not area, you're going to lose a point. Okay? So 49 pi, or 153.86 centimeters squared. Can I show you that this is rounded and not exact? I'm going to. That was a rhetorical question. Not sure why I asked it then. So instead of writing 49 times 3.14, let's say 49 times, do you see the pi button here? It's a lot more than 3.14. You see it's actually much longer than that. And we get that. So you can see that our answer is rounded. So, and that's a rounded answer as well, based on the calculator. So 49 pi is the exact answer. 153.86 is our rounded answer to the nearest hundredth, according to what we use for pi. Not according to actual pi, which would be 0.94. All right, all that to say this. You need to know this formula. Okay? So, a good study tactic before our next test and before the Iowa test here in 3 weeks would be to make a list of flashcards of what are formulas I need to know, circumference, area, etc. Yes?
Tomorrow, if we get a problem like that, can we use calculator?
Yes, can and should. You will also see that the book recommends you use a calculator on lesson 89, which we'll approach here in just a few minutes, okay? All right. Other questions before we move on to 87?
Will we use the calculator on the EOG?
Yes. It's not technically an EOG, though, so but yeah, I think you get a calculator. You have to bring it, though. Bad time, not yet. Give me just a couple minutes, and I'll try to set you free for a few. So lesson 87. So 86, again, was really, really brief. Just the area formula for a circle. Okay, again, read over that some. Finding... Now, this is not how I would title this lesson, but it's what the book uses because it's going to be just a small subset of these skills. You actually have probably been doing this before, but suppose we had the equation 3a equals 36. Okay. First of all, what is meant by 3a?
It's a placeholder, or it's like it holds it's a number.
A represents some number. Good. It's a placeholder. That's what a variable is. What is meant by smacking the 3 right beside it?
Multiplication.
Yes. Multiplication or times. So instead of just saying 3a equals 36, we understand it to mean 3 times a equals 36. So a becomes a missing factor, as in a missing number that's multiplied by 3 and spits out a 36. So you can look at that probably and tell me what a equals. It's 12. And you can test it, right? 3 times 12. What is that? 36. Okay? So, how could we find the answer to that? If we don't just know, 3 times what's 36? That's my times table, so I'm good there, right?
Divided by 3.
What?
36 divided by 3.
How'd you know to do that?
Good friend.
Wrong answer.
Crap. I went to 4th grade.
What did they teach you in 4th grade about multiplication and division?
Because whenever your answer in division, like your you can say why I don't know what it's called, but whatever number that's right here, your answer if you multiply by that is like this. It's right there.
So you're telling me there's a relationship. Macy, you want to expound on that?
They're like opposite. Right there.
They're opposites. Okay, so because 8 times 9 is 72, we can say 72 divided by 8 would be
9.
Yeah. Or 72 divided by 9 would be
8.
the other one. Right?
Divide 3 by 36.
No, you do 36 divided by 3.
Same thing.
Not the same thing. Many of you missed that problem on the test as well because you did 15 over 60 was 4, not 1/4. So the order matters when you divide. Agree?
Yeah.
All right. All that to say this. You know how to do this a lot in your head. A does equal 12. But what we want to do is think, okay, 2 things multiply to get 36. I can take 36 and divide by the one I know to get the answer. Okay? Now this is just the baby step to what you're going to do next year. Those of you who take algebra half. You're going to have to do next year if you don't next year. So,
Yeah, I'm not doing that this year.
anyways, it's coming. It's coming.
Can you choose if you want to or not?
I don't know. Probably.
Next year you can.
But what if it's not on our times tables, like just from memory? What if it's something weird, like 28b equals 84?
You still have to do the same thing.
True. How would you do that, McKenna?
20 or 84 divided by 20.
Good. So then we'll take the product, which is 84, we'll divide by the one we know, and it will give us b.
I was just guessing.
That was a close guess. The method was right. The method is what matters. The method is what we're learning about. So there's a relationship here that multiplication and division are opposites. I'm just quoting Macy here. If they are opposites, then that means one will help solve the other's problem. I'll say that again. Opposite operations solve each other's problems. It's not like yin and yang, but that's what comes to mind. Opposite operations solve each other's problems. So one final thing here, which you don't have to do in this class, you will have to do in Algebra Half. Suppose we had a problem like this. 7c equals
27B.
60. You know, 'cause it's not going to be a nice, pretty answer. What I would hope you see, first off, yeah, you could just do this. But where we're going, we're treating this equation like a balanced beam. And it's equal on both sides, or balanced. And so we can do something to both sides. We can say, I'm going to divide this side by 7. I'm going to divide this side by 7. Why do we do that? Well, that's because of what Macy said, that they're opposite operations. They solve each other's problems. Don't believe me? Well, what's 7 divided by 7? And 1 times c is just itself. So you see that it got rid of the 7 on that side. It allowed me to figure out that c is equal to 67ths. There's no need to turn that into a decimal or a mixed number when 67ths is perfectly fine. Okay? Now, you don't have to do this in this class. You simply have to understand that you use division to solve multiplication, missing factors. Okay? But this is where you're going to go, so it's helpful to start thinking about it this way. Questions?
What does that say, like, up there beside the B?
B here?
Yeah.
B equals 3. That's just a really terrible arrow. B equals 3. All right. 87 is pretty simple, too.
But 88 is complicated.
I don't remember. Let's see. All right, and just like normal, we're going to have homework practice on all 4 lessons.
Are we doing the homework practice right now?
No. Lesson 88. Oh, use proportions
I was right.
to solve problems. All right, so I'm going to borrow over here for a second. No, I'm not going to do that. I'm not gonna do that. Yes? I have to let Carter go if I let you go. Okay, fine, both of you. Go ahead. All right.
Can I go next?
Can I go next? Can I go?
Is it worth 1 minute of your time after class?
Yes.
No.
Okay. Use proportions to solve problems. First off, what is a proportion? A proportion is one ratio set equal to another. But I wrote fractions because fractions are ratios, okay? So the first thing you must know is that a proportion is one fraction set equal to another fraction for the purpose of solving a problem, usually, okay? So let's see. For every let's connect it. Anybody watching basketball this weekend? Let's make a connection there. For every 3 households that watch the NCAA, let's say there are 20 chicken wings eaten.
What's up, NCAA?
Okay? People who watch. All right, so
What does that say? Household?
yeah. How many
Oh, watch.
wings would be eaten for 120 households? Okay, so yeah, make the problem up as I go. this is the blueprint. You guys know what a blueprint is?
Yes.
It's like a picture of the plans for a house or a building or a structure. This is the blueprint we're going to use.
Couldn't you just?
Hang on. A fraction said equal to another fraction. Now, what were you going to say?
I was gonna say if it's you have to divide 3 by 120, you could just divide 3 by 12 and then add a 0 and then divide multiply by 20.
You have to divide?
What? It's 40. 3 divided by 20 or 120. What are you doing?
20 divided by 3.
120 divided by 3. 40.
Yeah, same thing, but it's 40.
It's not the same thing.
40. She knows what to do. She just can't say it right.
Okay. I see. Hold that thought, okay? Because you can use that, but I want to show you where that ends up. What I'd like for you to do, because this is going to make it so much easier, this is actually how you could have done the fencing problem. What's one fraction we can write? For every 3 households that watch NCAA, there are 20 wings eaten. That's the ratio. Every 3 households, 20 wings. So I'm going to do that. I'm going to do 3 houses, 20 wings. Now, if it's a proportion, then I'm going to set it equal to the same units, but maybe different numbers. You see, the goal of this is to be able to solve for something that's missing. How do I know something's missing? It asks the question, how many wings? So what am I going to write for the right side fraction? What was I given in this question?
Let me think of it first.
120 houses. Okay? In the same way that I was given 3 houses and 20 wings, all I'm going to do is connect or set equal. Yes, Adeline, you can go. Set it equal to the same ratio, which is scaled up. It's just an equivalent fraction. You mean that's all a proportion is? Yeah, kind of. Gracie? What? Yeah, that was the deal. 3 houses, 20 wings. Blame Sophia, I almost forgot. What goes here? This is why it's important that you use units. You understand my ratio has to be the same units, the same order. What? 1? No, not 1.
40.
I'm going to just use the letter W. We don't know it yet. You might have it, but we don't know what it is yet because that's what we're trying to find. Okay? That's the goal, to be able to figure out how many wings will I need if I want to supply all 120 houses with wings in my neighborhood. That's a crazy idea. So I left it W. I left it like McKenna described earlier, a placeholder for something you don't know yet. It's really important to understand that's how we use variables, as placeholders. So last thing here, how do we solve this? What did we learn to do for proportions in a previous lesson?
Multiply.
Subdivision.
Oh, cross division. Cross multiplication.
Cross multiply. Yeah. Okay. So 3 and then that. So what's 3 times W? 3W. What's 20 times 120?
320.
Huh?
200. No.
No.
2400.
It was literally what y'all asked a second ago.
Okay.
On the board.
So what do I do here? Hey, this looks just like lesson 86. I'm sorry, 87.
Wait, we're not. Oh. Okay.
But it's 88. Funny how that works.
But it's 89.
No, it's 88.
I know.
Are you gonna, no more food?
Stop eating. No, you won't.
I didn't say stop eating, I just said stop bringing it to class. This looks just like the previous lesson. 3 times W equals 2400. What do I do to solve for W? I have to do the opposite of 3 times W. I have to do, what is it? I'm going to divide. So I'll get W equals 800. I need 800 wings. Okay? Now, McKenna,
Yeah.
you said there was something with a 40. Can you tell me where the 40 shows up?
I don't remember now.
Oh.
Wait. Oh. You could just divide, instead of doing 3 divided by 120, you could just do 3 divided by 12 and then add a 0.
But the answer is 800.
Yeah.
Cora?
You can do
And then you-
120 divided by 3.
Is what?
Yep.
And then
What's 120 divided by 3?
40.
Okay.
And then 20 times 40.
That's what I was going to say.
So if you multiply the households by 40, you have to multiply the wings
By 20.
by 40. 20 times 40?
800.
See, I
Hungry
did
now?
do it
Want
right.
some
I
wings?
did do that. That's what I did.
Okay. Okay.
Just so fun.
All right. But again, what I'm trying to get you guys to do, write the proportion. Yeah. Write the proportion, and then how do we solve a proportion? Y'all are really slow. How do we solve a proportion?
Cross multiplication.
Cross multiply. Okay? Look, I promise I'm not making that up. You just learned it. Okay? It's right there. That was the most recent lesson we did before spring break. Okay. So, last lesson? Yeah. All right, so we got 9 minutes. I got a whole 9 minutes. We're going to be good. So, lesson 89. Estimate square roots. Okay, first off, we got to understand what in the world is
A square root.
Yeah. Do you know, Ella?
I used to.
Noel?
It's the two numbers.
Is it two numbers?
by each other. Wait. Yeah, it's the same two numbers.
Okay, it's the same number.
Yeah.
And you do what with it?
Multiply it times 2 to get,
Not times 2,
By itself.
or by itself.
times itself. Okay, so if I asked you a simple question like, what's the square root of 25? You would say
50. No, 5.
5. Because
Oh, you said multiply it.
Because 5 squared equals 25. Right? Therein, if you understand all of that entire line, the square root of 25 is 5 because 5 squared is 25. And if I take some time for you to digest that, or if I ask you something like the square root of 9, that's 3. Why? Because 3 squared is 9. Okay? And then why don't we do one more? The square root of 49 is 7 because 7 squared is 49. Now,
Oh my goodness, you use BC. Can we use BC if you use BC?
sure. Sure. Because.
No, it's before Christ.
True, but it's because right now. Can you do that with any number?
No. No. If it's like, you can't do a prime number. I don't think.
True, you can't do any prime numbers. But what if I asked you something like the square root of 20?
4. Or 5. I don't know. No, there isn't. Because it has. You
It
can't
doesn't work
multiply
with even numbers.
Okay, there is one, but it's not 4, and it's not 5.
It's 6.
What relationship does it have with 4 and 5, though?
It's not.
That's coincidence. That's a really happy coincidence, but unfortunately, there's nothing else to it. What would it be between? That's what I'm getting at.
4 and 5. Supposed to be this.
All right, how could you prove that, Noel? We already have the square root of 25 is 5 up here. So should we do, wait, what is it that has a square root of 4? What number is the square root of, I'm sorry, what number has the square root that is 4?
16.
16. Now I want you to think something. That's the purpose of this lesson is to understand, first of all, what a square root is. It's a number that can be squared to produce this product. And then second of all, the square root of 20 is not a whole number. But we can estimate that it is between 4 and 5. Why?
Is it 4.5?
No.
Is it 5.4?
Maybe it will.
No. No. You see,
Is it 4.5?
guys. Okay. Shh. We can only do some square roots rationally, as in they have an answer that's a whole number. 1, 4, 9, 16, 25, 36, 49. Who can continue that?
56.
No.
64.
64,
81.
81,
100. 144.
121, and then 144. You see, all we're doing is the perfect squares. Those are the perfect squares because they have square roots that are rational integers.
They multiply by themselves.
Yeah, they were produced by multiplying a number by itself. But that's not, every other number doesn't fit that definition, okay? So, the square root of 20 has to be between 4 and 5. Why? Because 4 is the square root of 16, and 5 is the square root of 25. 20 is between those numbers, right? That's what I'm trying to get you to see, is that this lesson just wants us to be able to say, well, it's between what numbers? Between 4 and 5. Now, yes, some of you are probably thinking, can't you just type it in on a calculator? You have an inside voice like me. So you type. So here's what I'm going to do. I'm going to type 20, and then I'll hit the square root button. We said it's between 4 and 5, right?
Yeah.
Our reason was 4 is the square root of 16, 5 is the square root of 25, and 20 falls right in the middle of those. So let's see if our logic
I think it's
is
4.
true.
Okay.
Oops.
No, it's not. Well, I wasn't right.
Square root.
What
That button right there.
thing got?
Okay. 4.472135955. Do you think it stops there?
No.
Why does it stop here? My calculator can only fit however many digits that is. But the square root of 20 goes on forever, just like
Infinity.
pi. Okay? That's a little bit of a definition of an irrational number. It's not a simple whole number. It's not something that has a decimal that stops. It goes on forever because it's irrational. All right. So, let's estimate a few more before you leave. The square root of 40. The square root of... and by estimate, I just want you to give me two numbers it's between. The square root of 90 and... Whoa! Those is kind of hard. All right, so just those three. Write down what those are between. Don't give me one answer. I want you to say, hey, that has to be between this and this number. Okay? Oh. USB outlets. Come on, man. You guys got them?
Yep.
So, what two numbers is the square root of 40 between?
6 and 7.
Good. Between 6 and 7. What about square root of 90? Nope. 9 and 10. Because 9 squared is 81, 10 squared is 100, 90 is right in the middle. No, it's not 9.5.
The 7 doesn't have a square root.
What are you talking about, 7?
You said 6 and 7.
Yes, so the square root of 40 would be bigger than 6 but smaller than 7. That's what I mean.
What's that?
6 point something. And then the square root of 169 is 13.
Oh, I did that.